I was on mute, I think, until now. But anyways, I think we can get started. Uh, so, a warm welcome to our audience to the 24th webinar of GFI Ideas India webinar series. I am Akshay Bhatt, the Cultivated Meat Science and Technology Specialist with GFI India, and will be hosting this exciting session. Rules of engagement here before we move into the webinar is that you, as a participant or participants, can use the Q&A button for questions to the speaker or speakers, and also feel free to use the chat, but please do not use it for other topics or any other kind of internal discussion. Also, after the webinar, we'll have a Q&A session where all the questions will be answered. And also participants will be given the option of asking the questions live. So please click on the raise your hand button by clicking on the participants button at the bottom center of your computer or your phone screen. So before we jump into today's exciting session, I would like to give you a brief about the Good Food Institute. So the Good Food Institute is a non-profit organization that is dedicated to accelerating the shift to a sustainable and healthy and just food system globally. Our organization employs over more than 100 staff around the globe with 3 key programmatic areas. In science and technology, a team of PhD scientists work to advance and open source the foundation science of alternative proteins. Our corporate engagement team builds relationships with some of the world's largest food manufacturers, corporates, meat companies, restaurants, and retailers to help them capitalize on opportunities in the alternative protein sector. We also provide support to entrepreneurs and startups, as well as investors and financial institutions. Our policy team advocates for fair regulation of plant-based fermentation-derived proteins and cultivated meat, and lobbies for government investment for sustainable protein research and development. So GFI plays a very unique role in the alternative protein and the smart protein ecosystem. As a non-profit organization, we maximize our impact by sharing knowledge freely in a field where many innovators seek novel solutions to the same set of problems. GFI's research, data, and insights are open access and support the progress of every innovator in this space. So we also focus on white space. GFI advances high-impact, tractable solutions in areas where too few people are working. We always take a big picture perspective. GFI or GFI India works across the plant-based fermentation and cultivated industries, the private and public sectors, and international borders, as well as into the future decades. We spot and address today's industry-wide challenges, and we forecast and avert any obstacles which come for the sector to grow across globally. So the key question which we are trying to address is how we'll feed 10 billion people by 2050. And given that the United Nations expects that meat demand is going to grow by like say 50% in that time, how will we do so sustainably, efficiently, as well as safely? So industrial animal agriculture is among the top 2 or 3 most significant contributors to the world's most pressing environmental issues, such as water use, air pollution, as well as loss of biodiversity. It's also a very inefficient way of producing food. It takes, for example, 8 calories to feed a chicken to get 1 calorie out, and the calculations are much worse in terms of pigs and cows. So considering safety, for example, antibiotic resistance and pandemics, which have been driven by zoonotic diseases, are among the one of the biggest threats we face today, as these risks are driven basically by animal agriculture. So we believe that the answer to many of these issues is to make eggs and dairy that people love in a way, in a much more sufficient, sustainable, as well as efficient way. So with smart proteins, we can make proteins directly from plants, fermentation, or using animal cell culture instead of asking consumers to give up foods which they love. GFI is accelerating the path towards creating smart proteins by helping companies, startups, entrepreneurs make products which are delicious, affordable, as well as accessible to everyone. So at GFI, we see alternative proteins fitting into basically 3 categories, that is plant-based, cultivated meat, as well as fermentation. So in essence, plant-based meat is a term that people use plant-based ingredients to make plant-based meat or egg or milk products, which look, taste, as well as cook like conventional meat when I speak about a plant-based meat. And the second segment of the smart protein sector is basically cultivated meat, which often referred to as cultured meat, cell-based meat, and a bunch of other names. It's identical to animal meat at the cellular level, and it provides the same sensory as well as nutritional profile as conventionally produced meat. It's also important to note that it is not synthetic meat, so please don't call that synthetic meat, as well as it's not lab grown, because ultimately it's going to grow outside in big fermenters or bioreactors or cultivators, right? So, and then we have the third third pillar or third segment, which is called as fermentation, which is being increasingly used in the smart protein industry, not only to produce standalone proteins, for example, but also create high value functional ingredients. So fermentation is really emerging as a driver for, let's say, plant-based and cultivated meat hybrid products, for example. So we have three different segments in fermentation. That is traditional fermentation, where microorganisms are used to modulate plant proteins. The second one is biomass fermentation, which basically leverages on the fast, rapid growth of, let's say, microorganisms to produce high protein content. And the third one is precision fermentation, which basically uses microbial hosts as cell factories to produce very high value functional ingredients. I'll not go into the details of this because I think there is an exciting session on basically focus on cultivated meat right after. So in terms of broadly what we do at GFI India is basically, for example, we do the Smart Protein Innovation Challenge, wherein which we build capacity in terms of graduates, researchers, as well as early stage professionals. We give them the platform to learn about this sector, events interest, and come out with ideas and innovations. We also have a dedicated track which is focused on entrepreneurship, and we give access to curated webinars as well as mentorship sessions and a bunch of other resources as well. And in terms of creating protein innovation hubs, we are establishing centers of excellence across top tier universities, organizations across India. We also launching open access, let's say, grant programs in smart proteins, and also opening up coursework across universities. That's also a part of talent pool development, where we are launching smart protein curriculum or coursework across universities, and we also place ourselves within, let's say, incubation as well as bio-incubators or accelerator programs to bring special interest on smart proteins. So we also fund, GFI Fund has funded since 2019 $13 million towards open access research. Our competitive research grant program supports research teams across the globe who are conducting cutting edge open access research projects, improving organoleptic properties, costs, driving down the cost, as well as scale up of alternative proteins. So our Sustainable Seafood Initiative funds high impact research to address critical challenges facing plant as well as the cultivated seafood sector. So, so if you want to visit our website, that is www.gfindia.org. You can also write to us if you have any doubts or any insights or inputs in our sector, or want to learn more about the work we do. Please write to india@gfi.org. And without further ado, I would like to introduce the speakers today. Firstly, we have Dr. Madhusudana Rao. A brief history about Dr. Madhusudana Rao. He joined the Center for Cellular and Molecular Biology, CCMB, at Hyderabad in 1988. After completing a PhD in biochemistry from the National Institute of Nutrition, Hyderabad, and a master's in agriculture from Punjab. As the CEO of AIC CCMB, Dr. Rao desires to set up processes as well as technology translation or transition of discoveries in institutions as well as universities, establish an ecosystem of stakeholders from industry, investors, IP, as well as regulators for smooth transfer of technology as well. So Rao specializes in the area of protein engineering as well as nanomedicine. He has more than 110 publications and 11 US patents in his name, and has guided more than 15 PhD students throughout his career. He's also a member of several national committees as well as and also has managed several projects in collaboration with several international agencies. So Madhuji, thank you very much for joining us. It's great to have you for this session. And next we have Dr. Thank you, Madhuji. And next we have Dr. Sandeep Sharma. Sandeep Sharma is a seasoned bioprocess engineer with approximately 20 years of experience in research and development as well as manufacturing. He has worked with several organizations such as the Serum Institute of India, Panacea Biotech, MSD Wellcome Trust, Hillman Labs, as well as Premas Biotech. His expertise mainly lies, majorly lies in novel upstream as well as downstream processes related to biosimilars, vaccines. And he has 8 international patents and several top-notch publications in highly respected journals across the globe. So a warm welcome to you as well, Dr. Sandeep. So I think we can move forward, and Dr. Rao, if you could please share your presentation and with the audience, would be very nice. Thank you. I'll just stop sharing the screen.
Yeah, good evening. Thank you, Akshay, for very, very kind introduction, and GFI for giving an opportunity for us to say something that we have been doing for a while. This is a master class in cultivated meat. GFI, I've been associated with GFI for almost now 4 or 5 years, and I'm so it is such a professional society, and works very hard towards the smart protein innovation and then alternate proteins, future of the proteins, all these things. And then some of the background for the vision and mission of GFI has already been said by Akshay. That I think probably all of you are already aware of. So what I would be doing in this next maybe 25-30 minutes is to tell you something briefly about why we got into it and also what we try to do and where things are going in the rest of the world. Very briefly, so we can catch up if there is anything missing in the last part of the session, I guess. So first comes disclaimers in the sense, when you read anything, like for example, if you were to Google clean meat in Google and look up, the first 2 pages will be on something that is kind of not very, it's not very exciting because most of the time people take it as if it's out there in the market, and then we are going to replace the farming animal farming industry wholly and things like that, which is very, very, very far from true. And one of the most important thing is as the world the population is going up, and then obviously there is more need for the protein and food. And looking at simply the current numbers, it is seems to be obviously unsustainable in many aspects. Some of the aspects Akshay has already mentioned. That's one. And people look at what is the acceptability, how clean is it. I mean, people are if you were to look at life cycle analysis of meat industry by the so-called clean meat route, it's not going to be affordable kind of arguments. And there's several things come up. But we are not there, but we are trying to get there. And this is the startup journey of the clean meat, which needs to be looked at it from a growing field, not as a mature field yet, because there are so many challenges which we touch upon as we go along. This is something very familiar with probably most of us, is the carbon footprint of animal grown for meat. If you look at on the y-axis, the impact and the energy use, one of the statistic Akshay mentioned about 8 calories versus 1 calorie for chicken, the amount spent and amount gained, the energy use, the greenhouse gas emissions, land use, water use. If you look at various animal footprints, they're very high. And if you look at cultured meat, obviously we are trying to reduce that for particular footprint. But of course, on the energy use, I think by today's calculations, it is still high. But I'm sure, as anything else in technology, once more people get into it, the the input energies and costs will definitely will come down, and that is the reason why a number of multinationals are interested in this particular technology, not only as a commercial activity or a way to make more profit, but more as a concern to the environment. Because one of the very challenging things to convince people is about the long-term effects of small things we do. A tree cut here may not, a person who cuts a tree may not realize its impact. We cannot convince what happens if I cut one tree. But as the message is coming from in all quarters, saying that the energy cost of the many things that we do today is going to be unsustainable as we go along, and that's what the global sustainable goals kind of state in several ways. I think we should take a very serious note of it, and this is one effort in the context of generation of feed, proteins especially. So uh, the uh, if you were to look at the overall, not only in terms of energy costs, one of the things people talk about, all of us are concerned about AMR, antimicrobial resistance. But at the same time, if you look around, the AMR is there because we use excessive antibiotics in various, not only on ourselves, but also 70 to 80% of the antibiotics produced are used in animals. Because it's a kind of a production process, people don't want any surprises, especially the major animal factories. So they kind of overload these animals, and then eventually they end up in our bodies because we eat them. So I was just mentioning about the antibiotic usages. So these are all something that we don't see directly, but they'll come back to us eventually. And I think the greatest example we all of us learned is the COVID. The occupancy of their habitats of the wildlife, and they come trying to find out new places and intermingle with the human population. And probably that's one of the reasons why how bats could transmit the virus to humans is one of a very, very popular theory. So it is something that we have to take a very proactive role in reducing these exigencies that we cannot afford down the line. So coming back to the technology of clean meat, this is a broadly, this is a kind of picture you see many places. So you don't have to kill an animal, basically. You just have to take a biopsy of the animal, mainly taking some part of the muscle tissue, and go back to the lab and isolate the what is called as a muscle stem cells, and then propagate them in a way so that because these stem cells have a natural property of propagating, because they're not differentiated cells. So one can propagate them ad lib for any number of generations. The number of generations one can do, it depends upon the smartness of the skills of the scientists. So some people can go to several tens of generations, some will have problem after few. So it's it all depends upon how well you characterize these muscle stem cells in various aspects. So one of the things that I show in the next slide is the process where you try to isolate from a bunch of cells, you isolate your muscle stem cells and do a very sophisticated separation using very good markers that are very important, like CD29, CD56, or PHX. So many things are there in this area, which are very specific for a particular population of stem cells. And then you take them, purify them by several techniques like differential adhesion and things like that, because their adhesion properties are different from the other cells in the same muscle. So use all your tricks to isolate the ones the best. So once you have these cell lines, please remember one of the major challenges in the clean meat technology is the quality cell banks. In fact, several projects are funded to create a freely givable cell banks for various users. In fact, that's one of the major challenges. A well-characterized cell line is a worth in gold in this particular technology. So keeping these things in mind, a joint project between CCMB, which is a CSR institute, NRCM is a ICR institute. A project was put up a couple of years ago, where CCMB comes up with a kind of lab-based cell culture kind of skills, and NRCM comes with a understanding of what kind of breeds one should be looking at, how to do the biopsies, and so on and so forth. And this is something that's a very exciting thing that happened between two institutes which wouldn't have seen each other because there's no overlapping interest otherwise. So what NRCM helped us to do, I just give you briefly what we have done in last 1.5 years or so, seriously, because we lost plenty of time in the context during COVID time. But one of the things that we took the help from NRCM, and they have an excellent job of isolating these, from, as I said, the cell banks are crucial. So one of the initial things that we decided to do was we focus on sheep. One could have focused on goat or beef, or pigs or chicken or crustaceans. But we chose to do it on sheep because looking at various, demands and the habits, consumer habits, we picked up sheep. And then from various aged animals. We isolated these cells and did a lot of cleanup, and then went ahead to isolate these muscle stem cells. As you see here, this tells you something about the development of muscle stem cells and the corresponding markers. So as a stem cell, a quiescent satellite cell becomes an activated satellite, and this is a myogenic progenitor, myocytes, myotubes. These are all the various developmental stages before it becomes a muscle fiber as we have it in our body. So at each stage, the bottom picture shows you how each marker comes up at each stage of this development. And these are the kind of handles that we use in our isolation methods, especially using FACS, fluorescent aided cell sorters. At PAX7 MyoD combination will give you these kind of cells like that. We have a very clear understanding of what comes when, and use that particular handle to isolate the cells and then grow them, and then validate their properties as we go along. So this is the kind of technique which was mostly my colleague, Dr. Josna Dhawan, who is an expert in this particular area, and she was handling most of this characterization part of the work. And the next slide here, what you're seeing is the division properties. So what you see here is population division times. These things are very important to quantify and also preserve these cell lines. Once we did all the previous stem cell isolations and things like that, we were looking at what is the division times, is it consistent? Like 3-month-old animal, 8-month-old animal, 9-month-old animal, 12 months old animal. So what we see is there is a consistency in its population division time, which tells us that one could isolate from anywhere below 1 year the muscle stem cells and go forward. And one of the things that I mentioned about was the cell lines. Once you make them, you'll have to freeze them for future use, because you don't want these cell lines to go on dividing, and then there is a issue of genomic stability, which you wanted to avoid to the extent possible. So you wanted to freeze them and revive them, freeze them and revive them, and see whether the revival properties are identical to what it was before freezing. So the picture that you see on the right side is an average population division times, immediate processing, post-revival, like that. We have done a lot of comparisons to make sure that these cells that we identified and preserve them can revive very healthily, which is very important for distribution. So this is something that we have achieved, and we have something like 5 or 6 cell lines with us, which we probably can give it to people who are interested in taking it up further. So the next slide is some kind of just to show what we've been doing in a plate, how the cell lines becomes myofibers, myoblasts, and things like that with various markers. And also what you see on the right side is some of the markers that myosin heavy chain, desmin, myonogen, beta actin controls at various our sheep cells, and the C2C12 is a standard cell line. Like that, we do and demonstrate that we are talking about cells that are, true to their behavior as a mother satellite cells. So this is one part of our work where we are trying to get a handle on the isolation, characterization, and establishing their initial division times, so on and so forth. And we have done several studies. One of the important challenges in this area is as you keep on allowing them to divide multiple times, at certain points, there is a kind of a problem that it doesn't divide further. There is what is called as a Hayflick's limit. There are several ways to overcome it. Very simple and known ways are using another viruses. But as this technology is supposed to be very intended to be very safe, and there is nothing that is untowards used in the development of this, we have tried to overcome this limit by small molecule interferences. So we have tested few of them. We have 1 or 2 very promising ones, but we need to establish their usefulness in a much more robust way, compared to what we have done today. So those things are still ongoing work. So as the cells divide, there is going to be a kind of genomic instability, as people know. And that's one of the reasons, if you Google about clean meat, they say they become cancerous in a test tube kind of a thing, which is kind of not correct. But at the same time, certain features that happen in cancer cells do happen when you allow the cells to grow multiple times, like 30 times, 40 generations, and things like that. But one can overcome these things by media, because there is a media manipulations that do not allow instability to creep in. There are plenty of work that has been reported elsewhere, but not in the context of clean meat. So that is something that's very interesting. If you look at the life cycle analysis, what is the cost component? Because one of the things that people raise their eyebrows when you talk about clean meat, and also you have seen it in the first slide, where the energy component of clean meat is very high. That's because the kind of media that you use, very expensive. Because what we do is an important component called fetal calf serum. In fact, it accounts for 80 to 90% of the cost of the media. When you're talking about making this clean meat in the range of hundreds of tons kind of a thing, you require the serum at a large quantity. So obviously, it is an animal origin serum, so we shouldn't be using it, because in our clean meat technology, which is supposed to be fermentation based, we cannot use anything that originates from an animal. So serum is out of the thing. So, but can we replace serum? Because we are all scientists. So if break the serum component and see what can be made without actually getting it from the serum. So one of the project objectives that we had was to make the growth factors. All of us know there are several growth factors that are crucial for cell growth, especially muscle cell growth. So we looked at the literature and identified some half a dozen growth factors that are important for muscle cell growth in the sheep. So we isolated these genes, these growth factor genes, from the sheep itself, and then sheep cells, and then put them in a bacterial system and expressed it. So that once you make it in a fermentation where you can make it in large quantities and overcome this cost barrier of 80 to 90% of using serum. And that is what we have done. So manufacture of growth factors by fermentation in microbes. These are the growth factors we have completed doing it, and showing a kind of a data that tells us that the purified IGF-2, basic FGF, and TGF beta-3, and things like that. So, and also we tried to attempt making albumin and transferrin, which we are not successful. Probably we will with a bit more effort. So we are also looking for somebody we can help them, and if somebody wants to do it. So this is something overall we have tried to do, is look at the problem from the cell culture point of view, and also look at from the cost cutting point of view, where we replace the serum with fermented growth factors. So these are, in our opinion, these are the major ones. But if you look at the kind of expectations, please remember, eating meat is an immensely omnipresent kind of a thing, habit. Like, it is very personal, it is societal, it is historical, it is evolutionary. So it is something that people are very much attached to, the way that we are used to eat meat. Like, it could be a kind of the steaks, the breasts, the legs, so many things that are people are used to, and it's part of our psyche, or all our neurons are kind of tuned to it. So we are not trying to get there where we are able to get a steak out of our fermented meat, but there is a lot of effort going in that direction, whereby people focus on scaffolds that are largely based on plant proteins of various kinds, so that again you don't go back to animals. So these are some of the things that one can, once you have a scaffold, you can bring the appearance of the kind of meat that people are used to. So these are all the very interesting challenges. When we got into this particular area, our interest, of course, is a clean meat, but there are so many smaller challenges that one need to overcome, which are scientifically challenging, not only from the commercial point of view, purely from cell biology or biochemical point of view. Also, there are extremely exciting projects if one would like to look at them. Besides that, contributing to the economy of the whole technology. So, the if you since though it was kind of a, if you look at 2016, there are only, you can count the number of companies that are involved in the clean meat kind of a thing, especially with the support of some of the major figures like the Google people or Gates foundations and like that. And that kind of infusion of investment have taken it a lot, taken the push the technology into a direction. And actually, we have had almost few years ago the first demonstration of a cultured meat in London from the company of Mosa Meats from Netherlands. So subsequently, there are a number of companies that have started, and then they are looking at various aspects of this particular technology. And as you see, these are all some of them are also in the Asia region, but most of them are in US or in Europe because of the funding that they receive from these majors, and also investments, and also from the animal companies like Cargills and things like that. The Shoik Meats that you see is a Singapore company, which is something that trying to do from the crustaceans. And there are several very promising companies that started from Israel. So it is really blowing up. And what I'm showing you is almost 3-year-old thing, but there are plenty of things that happen in this direction. So these are all the various companies that are interested in getting into various, aspects of the clean meat technology, whether you call it cell lines or the cell culture media, scaffolding, bioprocess. And what we are talking about so far is what can be done in the lab level. But that's maybe a 20% or 25% of the whole workflow, because the scaffolding, and I mean, basically you have to grow them, because all muscle cells are adherent cells. We have to promote not only a scaffold, but also a surface for them to grow and differentiate into muscle fiber, which is what we normally consume. So those kind of scaffolds that are largely protein based, like soya protein or custard breed proteins and things like that. And also, once you wanted to grow it in a large scale, the chemical engineers come into play. These are various things that one need to look at. But the fermentation based technologies are going to be a big deal, because they are green in nature, because many chemistries are also shifting to fermentation based production of molecules, so that the carbon footprint of these technologies is far less as we go along, which is a kind of imperative that all of us should be aware of. So these are all the supplier kind of portfolios and major challenges for a biologist. I would be talking about chemical engineers. One is pure primary muscle stem cells, marker validated, number of divisions, how to overcome. I gave you an example of ours, but there are several tricks. It depends on the kind of imagination of the biologist. Genomic stability is definitely have to overcome. There are several leads, but one has to spend time on it. Serum free media is obvious choice. A lot of people are working, and there are there are several major companies that supply, but today they are extremely expensive. But one more inputs into that kind of an area will reduce the costs, and then makes it much more affordable, the whole life cycle. So scaffolds is for a later day, because it's a next challenge. How do you make different scaffolds, and then understand the mass transfer properties of the nutrients, and at the same time the growth properties. And also these kind of things are extremely exciting. The 3D printers come into play, and it's a kind of interface for different technologies to come into play. That's why it's almost like what happened some 10-15 years ago for nanotechnology, where chemists, polymer guys, biologists, engineers, all of them have come together. And today you see nanotechnology is such a flourishing thing in many areas, because they see the whole advantage of something being nano. I mean, I'm just drawing a parallel here, because I spent some time in nano kind of thing. So the confluence of different technologies is very crucial for this area to grow. And in India, there seems to be a very good initiatives. In fact, probably ours, India is the second country in the world where the government supported a project on clean meat. This is a great initiative, but I think we should sustain this momentum and more people should get into it and then contribute. They don't have to think of clean meat as their personal choice, but as I said, there are sub programs that many cell biologists can contribute, and this is what I thought should excite the people around. And that is also the interest of GFI to promote these technologies so that we reach the goal faster than others. I think, thank you very much for your patience and listening. Thank you. I can stop sharing.
Yes. Yeah, thank you so much, Dr. Rao, for sharing insights, some very basic insights on the uh, mutton, I should say cultivated mutton project or cultivated mutton meat project. But yeah, I mean, there are several questions trickling down. Probably we can take them and then move on to our next presentation while thoughts are very fresh in our audience's mind. So we
Yeah.
have several questions from Swapnil, who's also an entrepreneur in the space of cultivated meat specifically. So his first question is, how many replicates have been made to obtain data for cell survival? Cell
Uh,
revival.
Definitely not less than 4, because some of these error bars that we've shown indicates each duplicate was done several times to make sure that there is an error bar that's been created. So minimum is 3. I think we have done 4. So that would give us a kind of variance that normally happens in a new system that we are working with, right? And the second question I see is what all stem cell markers are used for characterization. I think I've shown them, and then we use PAC75, myogenin, a large chain of, what was that, myosin. So, I mean, this is a question that my colleague Josna can answer because she's the one that executed this work. These are all just to demonstrate. I think some of these questions, I think I can come back to you because I don't want to talk about whether the blue colored cells came from which stain. I think that some I can cross check and come back to you. Please remember the question. I'll come back.
So
The
I mean,
current cell.
before you answer the next question, Madhuji. So just to let the audience know that Dr. Rao is heading the Atal Incubation Centre, right? So there are a bunch of startups there. So he's not technically heading the, let's say, the R&D of this specific project. So like what Dr. Rao said, it's basically Dr. Jyotsna who's leading the project. But obviously, I mean, Dr. Rao will have insights through Dr. Jyotsna, and he'll try to answer all these questions to the best of his ability. Please go on. Madhuji.
Yeah. In the current cell-based meat startups, are they turning the growing cells into tissue, or the final meatball is nothing but a group of cells that were grown? I don't think people have gone that far, at least in India, but abroad, plan where you kind of grow them at a pre-myofiber stage and then make them differentiate into myofibers and harvest them. And people have been successful in doing it, but at a lab level still. So that's what most of the startups try to overcome that. How do I differentiate by some kind of a mechanical things or some electrical things, some kind of, these are all the tricks that people
Can I add
try.
something here?
Okay.
So, I mean, just to answer that Yadidya's question here. So, ultimately, so we don't have cultivated meat in the market, right? So, ultimately, we'll have, I mean, to begin with, we'll have hybrid products in the market, like plant-based plus cultivated plus fermentation, kind of hybrid products, right? So, I think people are now just focusing on getting the cost down. That's the most important issue, and that's the reason why we have also enablers in the ecosystem where companies just focus on scaffolds, where companies just focus on serial media formulation, because all of these are so complex that one company cannot, they cannot just spread thin, like, doing R&D in all these, let's say 4 or 5 verticals of cultivated meat. And that's the reason why we have enablers who are stepping in and saying that, okay, you don't have to break your head for scaffolds. We are there. We are giving you the scaffolds. You just break your head about, for example, creating that cell line which is not GMO, for example, which is like immortalized without using any gene editing tools or whatever. So I think ultimately we'll be reaching there, but that's a long way to go, right? So right now this is what it is in terms of the sector. Yeah, but please go ahead, Madhuji.
Uh, how do you see the usage of cell lines in meat in India? Basically, like I think today there are not many players here, and the probably GFI can add more information on it, but we are one of the people who made some cell lines that can be tested by others. That's what that's the purpose of our project, but we couldn't complete in time for one of these things is the due to COVID and then the difficulties during that time. So but we are ready to explore with different partners if they have similar interests. And are these stem cells or adipose derived stem cells? How do you differentiate them? Again, we know that to complete a muscle tissue, you need both the stem cell, the muscle cells, and the adipose cells also, because the fat is a very important ingredient for this purpose. So we separated them out. We didn't use it. We wanted to. We had two approaches, but both the approaches we didn't really get so far. Is where we co-culture the adipose cells along with the muscle cells is one option, or you grow them separately and mix them in a final product. We made some initial experiments on adipose things, but we didn't go so far to talk about them loud. And is CCMB open? As I said, academic collaborations is what I was saying. I think we definitely will be able to share our knowledge and then help somebody who wants to go in this direction. The differentiation happened through serum starvation or serum muscle specific growth factors. Here, normally we use, there are several media we explored actually, which I didn't talk about them. But one of the things, the differentiation is more from, first step is in differential adhesion behaviors from the stem cells versus the other cells in the muscle. So that's one way to enrich the population of muscle stem cells. And then subsequently FACS-based separation using various surface markers. So isolation of these stem cells is mainly from using the surface markers. How was proportion of growth factors determined? We haven't completed it. We have done with 4 of them where we replaced the commercial. We made synthetic media using the commercial growth factors and started replacing one by one. And I think we have done it for 4 of them, and then we haven't done with all the 6 that we have expressed and purified. So that is far. You need to finish that work. Definitely, we didn't finish. Right.
Yeah, thank you so much, Dr. Rao. And if anyone has any question, please raise your hand, and I can, unmute you guys for additional questions. But giving it, let's say, like 30 seconds, we can move on to the next speaker here, Dr. Sandeep Sharma. So in the meanwhile, if someone has any questions, please raise your hands. I'll be in the meanwhile sharing the screen on behalf of Dr. Sandeep.
Hi, Akshay. Good evening.
Hello, Dr. Sandeep.
Hi, sir. Good evening, sir.
I think he's on mute, Dr. Rao. Yeah.
No worries.
Yeah. Good evening, Dr. Sandeep.
Good evening, sir. So, yeah. So,
So,
first of all, sir, thanks.
so just a minute, Dr. Sandeep, before you move into your presentation, there's one more question. I think this is a common question. So this is from Bin Mahesh. Does pedigree of source does the pedigree of animal source require approval from any authority before biopsy of stem cells, which is intended to be used as a source? Like I think just rephrasing, does it require any? Yeah.
Yeah.
Definitely,
So,
it is. An institutional ethics committee has to approve.
Right.
Especially we were looking at 3-month-old and 6-month-old animals. Though it is, we don't sacrifice the animal, but still we anesthetize and then use a lab-based methods to extract and do the biopsy. And we took the institutional ethics committee for this purpose. Yes.
I think, sir, is I totally agree to serve. At the same time, if we go ahead with chicken, then probably if we opt for a 10-day embryo, sir, so I believe that for that purpose, we do not need a approval. Like suppose if we
Okay.
give for go for 8 or 10-day embryonic cells, then I do not think so that we need approval. So I do not know whether I'm right or wrong, but you know better than me, sir. So this is my answer. So sir is right and I agree to sir. But if we go for chicken-based meat and if we go ahead with these embryonic cells now and if they're 10 days old or 8 days old, in that case, no approvals are required. But beyond that, we need approvals and sir can probably give his, I would say, advice on the same. Madhu sir. This is what I understand and know.
Yeah, I think you're right on that part. Yes.
Right, sir, right, sir, right, sir. So,
Yeah.
Akshay, first of
Thank you.
all,
Thank you. There's one more question, I think, from Priyadarshini. I think we are running a little late, but Priyadarshini, if you can quickly ask
Yeah,
your question. Yeah.
please.
yeah. Hi. Thanks for this information all provided. I have a question that the MSCs, the mesenchymal stem cells, they have if it is from the primary cells, they have a passage like 10 or 12 is a maximum thing we can use it for the experiments or the expansions. Then it's not in a sustainable way. I would say like only primary 10 can be used for the CM productions. Then we keep on extracting the cells from the animals. So how we can face this problem and bring the
Yeah.
solutions?
So, Priya, I would say Priya to you, Priya Tharshi, if I'm
Yes,
not wrong. Huh?
Priyadarshini.
Yeah, so Priya Tharshi, my answer to your question would be, see, we have just started and we are exploring things, fine,
Yeah, yeah,
and we know
true.
the ins and outs of the work. And as see, I answered to the question about whether we need approvals because for 8 or 10 days embryo we do not need any approval. So for the question your answer is, let's see, we are exploring things and we are going ahead with each and everything, keeping in mind about the ethical issues and what can we do, what we cannot do. So I'll answer you probably within the next few days. You can get connected to me.
Thank you so much. Yeah.
Yeah, 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 yeah.
Thank you. I think Dr. Sandeep, you can go ahead with the presentation.
Yeah,
Thank
so
you.
before I go ahead, first of all, I would like to say thanks to Dr. Madhu because he has already covered each and every aspect of cultured meat. And I'm thankful to him and because we have an incubation center at AIC now, and I've been in touch with Dr. Madhu. He knows the ins and outs. We are basically like students for him. He knows each and every thick and thin of the cultured meat. So this is one thing. And listened to him very patiently, and I totally agree to whatever he said. So for us, first of all, Akshay and Dr. Madhu, see, we have just started in the month of March. And as Dr. Madhu said, there are multiple things in this, I would say, cultured meat project. It's not about cell lines, it's about the scaffolds, it's about the bioprocess engineering, which includes the bioreactors, fermentation. Because me being a bioprocess engineer, I know the ins and outs. I've been in industry for 20 years and I around 8 patents. And whatever sir said, cost effective, how to make it cost effective, how to work on the media components or compositions which are novel and unique in terms of the costs as well as in terms of cell densities, doubling times, passages, because sir knows well than me, much better than me that see, as of now, we take around 12 days, 14 days, 24 days to culture uh, basically the molecule of interest. Fine. So the objective at this point of time is to bring down the costs in terms of reducing the culture times, working on the media components and compositions, which which would be probably much more cheaper and more effective, impactful than what people are using around the globe. Number two. Number three is Sir has already worked on sheep cells, markers, growth replacers, serum replacers. So this is what we intend to do in the future. This is our target basically. We have four different objectives. One is, first of all, establish cell lines, which is I would say the most competent struggling thing for all of us, whether it be chicken or sheep. So for Sir, my take is, Sir, if Sir can help us out in terms of sheep, which I've already talked to him, then we can go ahead with whatever has been worked and worked upon at CCMB until now. Regarding chicken, we are going to start our work very soon. We are at AIC, we are at U South campus, and by God's grace, we will be at NRCM also very soon. Because it's not a one man's job, whether it be me or Sir or anybody else. We need support from NRCM, from CCMB, from Sir Madhu Sir, because they are the experts. They have worked a lot on that. So this is my take on this, and we have 3 or 4 different phases. It's not about getting a vegetable, I would say, cell-based burger probably within the next 6 months. It's about establishing cell lines, establishing the scaffolds, edible scaffolds, or I would say scaffolds which are basically meet our demands as per the current status in the industry, and then the I would say bioprocess engineering in terms of the best fermentation designs, best processes, and I would say best media components. There are multiple things in the subject area, and I totally agree to Madhu sir. It's not a one-day job; it's going to be a long journey. And the advantage, which I personally believe, being I would say a junior person, is that there are people in India, but I do not know whether how many have come forward to CCMB or NRC until now. I do not know. There was a DVD project, but we as Neat Meatt Biotech Private Limited personally believe that we are passionate, ambitious, and we want to take this project ahead so that we can, rather than thinking about our benefits, we'll think about Indian population, which is quite huge, alternative protein source. So in short, totally agreeing to what Dr. Madhu said. This was my, I would say, perspective in terms of what I listened to him. And then regarding slides, they are quite basic slides. You can go ahead, please, Akshay. And the approach is to develop and produce cell culture based meat products, whether it be sheep or chicken. This is number one. And let's go to the next slide, please. Yeah. So if I talk about the Indian poultry market estimates, then see what we are thinking. So it's a hypothetical, I would say, thought that we target 10% of the premium end of the Indian poultry addressable market size, which is approx around 170 billion at this moment. And even if we talk about 25% share of the health consumer, then it is going to be another 143 billion for us. So this is in short about what we hypothetically see basically. And we do not claim that we are the first Indian company because there are multiple more players in India about which we personally do not know who are they. But we believe that we would be amongst the first company who will be working on lab-based meat solutions to mitigate all the problems which Dr. Madhu has already discussed in his presentation, whether it be antibiotic resistance or climate change. Everybody knows about that. And Atmanirbhar Bharat. So this is about what is our objective in terms of things. And there are multiple companies basically. We are planning to out-license our technology to consumers like I would say IDC, Godrej, Licious, or anybody who comes basically in front of us. And we are there to provide support in terms of scale up of manufacturing. We being experienced people, and in terms of bioprocess engineering, that is our, I would say, expertise in the subject area. About scaffolds, let me tell you very honestly to Madhu sir also, I discussed with DRDO because they invited me. On 9th of June, I was in Biotech Expo, and they have people who are working on, I would say, scaffolds and biomaterials since last 6-7 years, but they were not able to explore somebody who can join them or who can collaborate with them. And then there are people in Mumbai also, Maya Works, Shobhankar. They are working on scaffolds. So it might happen that in the times to come, to save our own time, if there is somebody who is working on scaffolds, we can take scaffold technology from them. We can have cell lines on our own. We can establish them, whether it be sheep or I would say chicken, with support from experts like Dr. Madhu or NRCM. We are open to that. Yeah. So this is one thing. And because of multiple things, if we think about going to the end product, which I believe Dr. Madhu will also agree to, we cannot say that we are going to serve, I would say, a cultured meat burger within the next 6 months to anybody in India. It's not possible. But as a team, if we go ahead, I personally believe that we would be able to deliver things to people, probably not only in India, even to the global south. Please go to the next slides, Akshay. Yeah. So, sir, the rationale is basically cooking for a sustainable planet. And this is a basic slide which tells basically that what we are going to do about GHG emissions and other things, climate changes, what damage is it is going to basically create. And in 2020, as you can see, US $210 billions in terms of natural disasters because of GHG, livestock management, etc. And so we are basically planning to have some novel sustainable approaches for probably sheep or chicken or both. Characterize them. Immortalization is a big issue, basically, at this moment. Establishing good cell lines after characterizing them is a big issue, which in itself is a commercial product, basically. So any company, not only me or anybody else, like, so we have different phases. If we have good scaffolds, we can sell them. If we have established cell lines, we can sell them. If we have a good bioprocess, we can sell it. If we have serum replacers, we can sell it. If we have growth factors, which are basically novel and unique in terms of each and everything, we can sell them. So it's not our target to serve a, I would say, chicken burger or patty within 6 months, but we are patient in terms of developing things. But obviously, for anybody, not even me or anybody else, end product has to be a chicken burger. It can be a soup also. It can be a soup also. So this is our target in terms of, I would say, uh, whether chicken nuggets or chicken steaks or whatever we do. So next slide, please, Akshay. Akshay, next slide, please. Hello. Yeah. So, sir has already presented a very beautiful slide. We all know that there are more than 40, 50 companies around the globe working on this subject area. And if I would if I can say that plant-based meat is probably, even one of my neighbor got ordered plant-based meat yesterday, and he was praising, oh, Sandeep, this is so wow to eat. So I believe that in the times to come, we can get comments from people, as Singapore is getting. Basically, they are accepting, loving. Michelin star hotels are being served by Esco, Esther, and companies in Singapore. Singapore Food Agency has given nod. So being a 60 lakhs population, they are so well equipped with each and everything. And we being multiple billions, so we have nothing in our hands as of now. So I think people like Madhu sir, GFI, and we who are passionate, we'll have to go ahead, because it's not a 1 day, I would say, project or a 2 day project. It's something which needs passion, dedication from all of us as a team, and especially experts like Madhu sir or Jyotsna ma'am, whom he spoke about. That Jyotsna ma'am was there with him. I do not know her, but I heard him. So we need people like Jyotsna ma'am, Madhu sir, or anybody who is an expert, who has basically dedicated time and spent time in working on the same project. I do not know why this project came on a backseat, but we are there to, I would say, join hands, shake hands with experts like Madhu sir and everybody who is there in India. So this is my intention. And as you see, my last point, we seek support from CCMB and RC, and we have already got support. We have an incubation center at AIC now. This was our first step. And next step would be to take mentorship, guidance, and I would say expert comments, advices from Madhu sir and people who are basically experts as per his advices. Next slide, please, Akshay. Yeah, so basically, I won't go basically ahead with the slide. So, sir, as you said, our initial target as of now, until we basically get blessings from CCMB and people like you, our plan is to work to go ahead with the chicken based meat. And what we are targeting as of now is that we want to work on myoblasts and then on adipocytes and fibroblasts. So we will isolate them from chicken embryo. We'll work upon them. We know about the markers, as you have already discussed about sheep markers. We know about the markers which are there in chicken, RT-PCR, fluorescent microscopy. So you are basically an expert, but I know what we have to do. So we are going ahead with that, probably with chicken embryonic cells isolation, and then immortalizing them to do mRNA extraction, to do RT-PCR analysis. So this is our first target, being nascent and naive in this field. We are just, I would say, kicking off our project with this intention that let's go ahead with chicken. And in the times to come, as we get, I would say, advices from experts like you, we are there basically to go ahead with sheep as well, because you people have worked a lot for I would say last 2 3 years. So we're more than happy to take over that work and then to go ahead in collaboration and in conjunction with the people, so that that work which has been done until now, it doesn't go in vain. We'll be with you, and we personally believe that we can just take it forward to the level where anybody else hasn't reached now until now. So next slide, please. Yeah. So, sir, this is nothing special. We have to develop cell lines, and it's an easy word to say, developing cell lines, for sheep, chicken, and then to develop and novel processes for isolation, co-culturing, characterization. Co-culturing is a big thing, sir. You know that very well. And methods to replace serum, I think you people have already done that. And I request you that if you can help us out in this aspect, we would be grateful to you. And then in the later stages, we would probably seek support in terms of establishing a unique and cost-effective fermentation process, which I personally believe that I do have that experience. At the same time, if somebody else has done this earlier, so I am in talking terms with most of the people who are experts in bioprocess technology, apart from me, because I am an expert. I do not claim that, but I have my colleagues who are experts. So this is going to be a later stage thing, not now, because the important thing is to establish cell lines. Yeah, sir. And mentorship is one of the biggest thing. So, so what at this moment I can say is that we are basically going ahead, culturing sheep and chicken cell-based meat, and if God allows us, we'll go diversify this to fish and other animals too. Next slide, please, Akshay. So, sir, financially, I would say that, see, it's a startup. We just got incorporated in the month of March this year. And I'm proud to say that we are with CCMB, almost with NRCM, at DU South Campus. So it was not an easy job to get people like you, Dr. Girish Patil, with us within 3 months of time, 4 months of time. We are proud. Why we are proud? Because we have experts who have already worked in this subject area. So we have just bootstrapped, and then this is all basically information which all of you know. So I won't go ahead with this. And we have basically applied for direct funding. For other fundings also we are applying because that is the, I would say, first and foremost priority for we being a bootstrapper or a startup company. And then there is a startup funding from CCMB also, for which we are applying, and we probably hope for the best. And until the time we get funds, we are there to manage each and everything in terms of financial modalities, whether it be recruitment, reagents, chemicals, class fairs, or anything else. Next slide, please, Akshay. Yeah, so sir, regarding timelines, I would say these are tentative timelines from hiring until partnership.
Yeah, please go ahead.
Yeah. So basically, it's from hiring until partnership or licensing. It's a tentative, I would say, proposal because I do not believe that whether we would be able to cope up with this proposal. It's a tentative proposal. So we expect that from hiring until partnership licensing, and wherein we'll have to in-license a cell and technology to accelerate timelines or to file a provisional patent application next 12 months. It will take us probably around a year or so. This is August almost. So we are targeting to get this done by September or October, which includes due diligence, which is already done, lab setup almost done, cell and development will be initiated probably next week, ideation, process development, scaffold selection, this is in process, and then IP filing, it will come later on. So we target to at least being very honest with ourselves, we just believe that we'll especially focus on establishing cell lines for myoblasts, adipocytes, fibroblasts in initial 1 year. At the same time, we will not only this, we'll sidewise work upon scaffolds. There are people in, if you know about MyoWorks, Shobhankar in Mumbai, there are people in DRDO. I had a meeting recently and probably I'll meet them on next Wednesday also. They are experts. They have a stem cell lab and there are people who have been working on biomaterial scaffolds since last 7 years, but didn't get opportunity to get associated with people like us. I talked to them probably 2 months ago. At that point of time, I never had even AIC was not there, NRCM was not there. So I told them, please be patient for 2 months. I'll come to you people. I'll give a presentation from the director DRDO. So they are working in scaffold. So this is basically what we're planning. We'll have to give a try. If somebody has worked, if somebody is passionate to help us out, then we can do co-culturing. We can prepare, I would say, primary cells, characterize them. We can give them to test their own scaffolds. This is our plan. So within a year, we expect to have, I would say, established, I would say, cell lines for adipocytes, myoblasts, fibroblasts, and as Sir said, Madhu Sir said, it might happen that we can make different cell lines for each of these three, I would say, myoblasts, adipocytes, fibroblasts. We can combine them and then we can work upon them. Regarding serum replacers, the sidewise things would be replacing serum, fetal bovine serum with, I would say, batch serum, growth factors, almost more or less same. And then scaffold work will try working hard at the same time, but our initial target would be being very honest with ourselves, working on establishing cell lines for all these three, I would say, on these three aspects. Next slide, please. So, sir, then there are multiple things, Madhu sir, regarding FSSAI regulatory things. So I know that there are no regulations as of now. We as a team are struggling hard in terms of cultured meat. People like you or Girish Patil, they are struggling hard, but we believe that it's not a one-day job. As we go ahead, as we progress in this field, I personally believe that definitely we'll get regulatory approvals in the times to come. So we have the option to out-license cell lines or the media components or the growth factors, which may develop during research and development. It might happen that we are ready with the growth factors or with the serum replacers or with the cell lines. So we are not dreaming big. Our dream is to get a burger with lab-grown meat. At the same time, we are not adamant. We believe if we have something in our hands before that, so the time will tell us in which direction we have to move. But the target is to go ahead until we get the end product, which is the chicken-based, I would say, cell-based burger or patty. So, yeah, next slide, please. Yeah, so sir, so I think Madhu sir has already presented this slide regarding who all are working basically on cell culture based meat products, and Singapore being the only country in the world which has given not approval and Michelin star restaurants. Basically, they are serving and people are this cultured meat. As Questor is supporting them, actually, well, and people are loving this meat. It's a 60 lakh population, so it's a surprising thing for us being Indians with billions, I would say, of people living in India. And if you see the population who gets interested, and people are spending enough money. Actually, we get these tikkas, or I would say kebabs, at cost of 100 rupees for two kebabs in the, I would say, local market. And people is spending 5 stars for those similar, I would say, kebabs. They spend 8,000, 800 or 1,000 rupees in a 5-star hotel for 2 pieces of kebabs. So I personally believe we have even a small proportion of the population who is interested in getting this kind of meat. And I believe me, the well, plant-based chicken, burgers, meat, people are basically ordering that in small towns like Noida. It's not a small town, but people are ordering that. They are loving it. So people are becoming aware. Those who are basically elite, or I would say qualified class, they are accepting this. And I believe that alternative protein source, apart from being those who are malnutrition or climate changes and multiple other problems like land management or antibiotic resistance, which laymen do not understand. कि हम क्यों कर रहे हैं? Why are we going with this kind of meat? But those who are qualified. Singapore, I mean, Singapore is 60 lakhs now. So I believe also at least 10 times population, so they will accept this. This is my thought process. So in the last one, as you see in bold letters, we have got support from AIC in terms of lab space, mentoring. I am requesting Madhu sir. He will be our guide and mentor. And I personally believe he'll be our guide and mentor. And scale up is something which will come basically probably later. At this moment, we are focusing, emphasizing on the R&D setups, especially in terms of establishing our cell lines, co-culturing, characterizing them. So this is our, I would say, thought process. Next slide, please. So I think this all has been done. I'm sorry for this slide because we already have got the support from AIC. We have the lab. We have, I would say, all the supports. I was in Hyderabad until day before yesterday. We got all the supports from AIC in terms of equipments, in terms of establishing our, I would say, lab. We have hired people there, and probably we are in the process of procuring things, chemicals, glasswares, reagents. That will happen probably within a week or so, because we have initiated that process. Regarding mentoring and guidance, I personally believe that I have been in talking terms with people like Dr. Madhu, who are experts, and I'm quite confident that we'll definitely get support from Dr. Madhu and the team and those who are expert in the subject area in India at least. Thanks. Next slide, please. Yeah, so regarding me, as you have already mentioned, I have a PhD in biochemistry with almost 8 patents, worked in almost 4 or 5 different companies in India, like Serum, Glenmark, Panacea, Hillman, a joint venture of Merck US, and Welcome Plus, a joint venture, Primas Biotech. So I have been in, I would say, R&D as well as manufacturing in different capacities. I've worked I've worked on almost 10 to 12 pediatric vaccines, developed technologies, transferred them across the globe. And then, apart from that, I worked on VLP-based corona vaccines, ophthalmic vaccines, oral insulin, multiple things. As you know that once you do PhD, it was in protein biochemistry. As you go ahead in life, so we are on the same platform. We become chemical engineers, we become bioprocess engineers, we become, I would say, polysaccharide specialists like Madhu sir. So we have to do each and everything in life. So this, and at this moment, I have Asim, who is a PhD and postdoc from Rosalind Franklin, who is a senior scientist at Delhi University South Campus with me. So Sushruta is a PhD in genetics, and lady who has an experience around 4 or 5 years in industry. We have one guy who has already worked on this CCMB NRC DVD project for 2 years, Santosh Kacham, whom we have hired for AIC Hyderabad. I interviewed 1 or 2 more people who are basically toppers from IIT Hyderabad and who are based in Hyderabad, because people generally prefer to be at their own native place because of personal reasons. So for here, I'm doing hiring for those who live nearby Delhi and around nearby regions. For Hyderabad, I'm hiring those who live near CCMB or within Hyderabad. Yeah. So next slide, please. Thank you so much. It's so you can see these cartoons, and this is my dream that if we can have all this, I would say cells at one point of time. Thank you so much. Thank you so much, Akshay.
Yeah. Thank you so much, Dr. Sandeep. It's good to see a cat here. Probably you're planning something on cats as well, even cat food or
It could
something.
have been fish actually. So it was my daughter actually who did this actually. I'm sorry for that.
No worries. That's so cute.
Yeah.
Uh, but thank you so much for presenting today, Dr. Sandeep. And I mean, open to the audience for any questions. I think we
Yeah,
are
please.
already over. It's been pretty late today.
Yeah, please.
This was supposed to end by 7:45. But if anyone from the audience has any questions for Sandeep, please raise your hands or yeah,
Please
there
go
is
ahead.
one raised hand.
Yeah.
Priyatashini asked to unmute. Please unmute yourself. Yeah.
Yeah, hi. Thank you, sir,
Hi,
for all
hi,
your great
Pridash.
information. Just curious to ask, are you selling these chicken stem cells now? Like, we are working in Singapore now, like in the CM research. So,
Okay.
if your cells are like very well characterized, then we
Yeah.
don't mind to buy the chicken stem cells from you so that we can
Yeah.
work on it.
Yeah. So can I call you Priya or Priya Tharshi?
Priya also can. Yeah.
So Priya, so happy to get your response. And I personally believe, see, give us some time and we would certainly get back to you. We will give you the cells. Don't worry about that. Give
Yeah.
us some
Okay.
time.
Yeah. The finding the cells is a crucial thing now. It's not available in the market,
I know.
so we will appreciate that.
Definitely, definitely. So for that, my answer is Priya. So we are in the process of working on these chicken cells probably from the next week onwards. And we have experts along with us. And I'm confident people like Dr. Madhu and from NRC, they will help us out. And very soon we'll have these cells with us. So please have some patience, wait for some time.
Yeah.
We'll
Yeah.
get back.
Sure. Thank you so much.
Thanks.
Thank you, Priya. So before, I mean, for anyone who's asking a question, probably you can just state yourself, your credentials as to where you come from, where you're working, or where you're studying, etc. So
Yeah,
Priya,
please.
where do you work?
Yeah. So I'm working in A-Star now. In Singapore. So I'm from Baridasan University in Trichy. So I came here Singapore for my project, and then I have been working here for 4 years.
Excellent. Wow,
Yeah.
great.
Thank you so much, Priya.
Yeah. Thank you for the opportunity.
And you
Thank
can
you.
take my email ID from Dr. Akshay, so we can get
Yeah.
in touch.
It's pleasure.
Yeah, please, Sandeep, if you could just type in your email ID, I mean, whatever contact
I'll,
details you want to type in the message.
I'll do that. I'll do that. I'll do that. Yeah,
Yeah, thank you.
sure.
Anyone else has any questions for Sandeep? Yeah, great. So I don't see any questions here. So I think we can end our session. Thank you so much, Dr. Madhusudana Rao and Dr. Sandeep Sharma
Thanks.
for your presentations. Very insightful and looking forward to what emerges, especially in terms of how Dr. Sandeep is looking into this space as an entrepreneur and what kind of challenges he has faced. So thank you so much for pointing that out. Dr. Rao, thank you so much for giving some very basic insights as to what are some of the technical challenges which your group or the group at CCMB has faced in terms of creating cultivated meat cell lines and moving forward into scaffolds. So we'd like to end this session right now, and everyone have a very good evening and a great weekend. Thank you so much.